Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Patricia Singer, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area matter and materials. The topic is particle model of matter, and the subtopic, which is our area of focus today, is density and states of matter. Let's look at today's lesson objectives. By the end of today's lesson, you should be able to describe the density of solids, liquids, and gases in terms of the particle model of matter, and explain why gases, liquids, and solids have different densities. All of this is sourced from your CAPS document on page 43. Pre-knowledge. This is what we've learned prior to today's lesson. In the 8th grade, which is in our previous lesson, we learned about density, mass, and volume. We learned that density is the amount of mass in each volume of matter. And if you remember that volume is the amount of space an object takes up, and mass is the measure of amount of matter of an object. So we learned about these three. Okay, so let's move on to today's baseline activity. I'm going to read out the questions, give you time to answer the questions, and then we will do the solutions together. The first question reads, how can materials be made to change their state? The second question reads, what are the two physical properties of a material that we need to determine its density? The third question reads, you have a 500-gram block of butter at home. You found out its volume is 555 mils. What is the density of the butter? And then the fourth question, how does the volume affect density when the masses of objects remain the same? So I'm going to give you 4 minutes to answer these questions, and then we'll look at the solutions together. Welcome back, learners. So now let's look at the solutions to the baseline activity. So the first question was, how can materials be made to change their state? So if you wrote, materials need to gain energy or lose energy in order to change their state, you got it correct. Don't forget to send through your answers to our WhatsApp line on 082-760-2630. The second question read, what are the two physical properties of a material that we need to determine density? Of course, we need its volume and we need its mass. So we need those two to confirm or determine density. And then the third question asked, if you have 500 grams of butter at home and you found that it has a mass of 555 grams, what would the density of the butter be? So here's the solution. Okay, so first we're going to write down what we know. We know that the mass is 500 grams and we know that the volume is 555 mils. Now, what is the formula for density? Do you remember from last week? So the formula for density is mass over volume. So 500 grams of butter over 555 milliliters. That is the volume of the butter. So now we're going to put our numbers down. So 500 grams divided by 555 mils is going to give us 0.9 grams per milliliter. Do not forget to put down those units. Units are very important because they tell us what we're working with. So in terms of density, grams per milliliter is one way to express its units. And then the fourth question, how does the volume affect the density how does the volume affect density when the masses of objects remain the same? How does it affect density? So the bigger the volume of an object, the lower its density will be. So please do send in your answers to 082-760-2630. Okay, let's move on to terminology. These are the terms that we're going to come across during the course of the lesson, and they'll help us better understand what we're learning today. So the first term is density. If you remember from last week, density is the amount of mass in each volume of matter. And then there's a new one today, dense. Dense is the amount of space an object takes up. Okay, so let's begin our lesson. Density. So density is actually a property that compares mass and volume. So the density of a material is actually the amount in a particular volume. So that is what we call the density of a material. So solids, liquids, and gases, they all have different densities. So a material in its solid state has a slightly higher density than the same material in its liquid state. And that same material in its gas state has a much lower density. Okay. So if we look at these are the three states of matter. We have solid, we have liquid, and we have a gas. Now look at the way the particles are arranged. Let's talk more on that. So in general, gases are less dense than liquids, and liquids are less dense than solids. This is because the particles within these three states are arranged differently. Let's go back to the picture that I was referring to. So the particles in a solid, like we've said in our previous lessons, are packed in such a manner that they are so close together. Think of the particles as my fingertips here. So if they are solids, they are actually touching each other, and all they do is vibrate around the same point. With liquids, they are a bit further apart. Remember from last week, we spoke about forces that hold the particles together. So the forces that hold the particles together within liquids are weak. So that's why liquids have space between them. Liquid particles have space between them, and they can flow over or on top of each other. And that's why you can pour your tea, you can pour your cold drink, you can pour your water. So liquids are able to flow. And now when it comes to spaces between the gases, they are much bigger. The spaces between the gas particles are much, much bigger because the forces that hold the particles together are quite weak. So their spaces are bigger, the particles are far apart. So that is why a gas fills up the entire space. So that's how different particles are actually arranged. Now, so the closer together the particles are, the greater the mass of that substance in a given volume. That's why most of the time when we're comparing solids to liquids, the masses are actually different. And we find that our solids are actually heavier. They have a greater mass because the particles are closely packed together. So the particles in a solid are closely packed together and resulting in a greater mass in that given volume. Okay, so as a result, solids generally they have the greatest density than liquids, and then lastly gases, because of the way the particles are packed. So with solids, remember we said they're tightly packed, and then with liquids they're a bit loosely packed. That's why liquids can move and flow on top of each other, and then with gases they're sparsely packed. Okay, now let's look at this diagram here. I've got a box of smiley faces. So we'll start off with the gas. We said the gas is less dense, right? We said the gas is less dense, therefore having a smaller mass. You see the spaces in between these particles. You see the spaces in between these particles? They are quite big. The spaces are quite big. When we go to the liquid, the spaces are still there, but the spaces are smaller in comparison with the spaces between the gas particles. And then when we move on to the solid, there's very small space. I'm just going to draw some red dots just to show you how small the spaces are. Just to show you how small the spaces are between the solid particles. So now let's talk about the density of water. Yes, the water that you drink. So water can exist in 3 states of matter. Water can exist as a solid, and we call that solid ice. We call it ice. And water can also exist as a liquid, and then we call it water. That's the water that we drink, right? And then water can also exist as a gas. So that is your steam, or you can call it your water vapor. So water can exist in all 3 states: solid, liquid, and gas. Water can exist in all these 3: ice, water liquid, and water vapor, or steam. So when water freezes, the spaces that it has between its particles, they become larger. What do I mean the spaces become larger? I'm going to take a bottle of ice now. Look at this bottle of ice right here. Do you see how it has extended the back of the bottle? Because the spaces between the particles have become bigger, so it has expanded. So the bottle has expanded. Same effect that it has when you put your cold drink bottle in the deep freezer for too long. The bottle is going to expand. So it's going to fill up all the space. So once frozen, the mass of the water now occupies a bigger volume. Remember how we defined volume last week? We said volume is the space an object occupies. So the space that the water occupied has actually become larger. That's why the bottom is more rounded. It's stretched out, it's extended, and the water has frozen and filled up the whole entire pot, even up to the bottle cap. Okay, so that is how water freezes. So ice is actually, because of that, ice is less dense than water. So that is why when you put your ice cubes inside your water glass, they float on top of the water, because ice is less dense than water and therefore flows on the water. So the particles in liquid water are actually more packed in comparison to the particles on the ice. They're more packed in comparison to the particles on the ice. And this means that more of them will fit into a given volume. So here's a picture of the three states in which water exists and how the particles are probably arranged. So we've got solid ice, we've got liquid, and we've got a gas, which is your water vapor and your steam. So that is the density of water. So if ever you're wondering why your ice is a solid, but then it floats on the water, now you know. So next. So ice is actually an exception in which water in its solid state is less dense than the liquid. All this time we've been saying solids are more dense because the particles are tightly packed together, but water is actually an exception. So that is why we need to explain the density of water. So look at this class here. You see the ice cubes are floating on the liquid because the ice is less dense than the water. And here is particle arrangement. Now, so this part here represents solid ice. Remember when I said when water freezes, the spaces in between the particles becomes larger. You see how big these spaces are? When normally when you think of a solid, you think of a much tighter situation. So the spaces actually become larger. If you compare this, the ice and the liquid water, when you compare the solid ice and the liquid water, you see the spaces in the ice are actually bigger than the spaces in the liquid water. So that is why you're going to have your ice floating on top of the water, and then the water vapor has much bigger spaces and it floats in the air. So the density of a gas is not fixed. The density of a gas is not fixed, but solids and liquids do not change their volume, so which renders their density fixed. It renders their density fixed, but the volume of a gas is not fixed and it can change. Remember, we said the volume of the gas fills up the spaces. So let's look at these three pictures. We have a solid with a fixed volume, holds its fixed shape, doesn't change. So the volume remains fixed, hence the density is fixed. Remember the two properties that affect density that we use to calculate density, to determine density, are volume and mass. Now, let's look at the liquid. The liquid also has a fixed volume. Even if it takes the shape of a container, pour 100 mils of water from a beaker into a coffee cup, it's still 100 mils. Pour that 100 mils of water into a bottle, it is still 100 mils. So the volume is fixed, it does not change. But now, when it comes to the volume of a gas, the gas always takes up the volume of the container. It always takes up the volume of the container. What do I mean? Say I have a bottle, a 500 milliliter bottle, and I fill it up with gas. If I take that same gas and transfer it into a 1 liter bottle, the gas is going to do what? It's going to fill up the available space. It's going to fill up the entire space. So once it has filled up the space in the 1 liter bottle, the volume has changed to 1 liter. The volume would have changed to 1 liter. So you see why the volume of a gas, we're saying it's not fixed, it changes. So when volume changes, it's going to affect the density. So the density of the gas has also changed. So that is why we say the density of a gas is not fixed. It is not fixed. Okay. So let's look at the density of different kinds of particles. Now, so the density of a material will depend on the type of particles it is made up of and the size of the spaces between them. So 1, the type of particles it is made up of, and 2, the size of the spaces between them. So the high density of a solid material explains why it cannot be compressed. That high density. Remember we said the spaces between the particles in a solid are very small because those particles are tightly packed and don't move much. They only vibrate in that particular position. So the particles of a solid are tightly packed and cannot be squeezed together into a smaller volume. I'm going to take a Rubik's Cube here just to show you. Look at my Rubik's Cube here. No matter how much I try and squeeze it or compress it, I can't. The particles are already closely packed together. Just think of the individual squares here in the Rubik's Cube as the particle. The spaces between them are already quite small. No matter how much I try and squeeze or compress, I can't compress it. So that's what I mean by the particles of a solid are tightly packed and very difficult to compress. Actually, I cannot compress them. So when we look at the density of a material, remember we said it depends on the type of particles it is made up of and the spaces between them, the type of particles it is made up of and the spaces between them. Let's talk about liquids. Liquids are also very close. So the particles within a liquid are also very close. So the density of a liquid is roughly the same as the density of a solid of the same substance. This is because the particles are close together even though they are not locked in fixed position like in the solid. Remember with solids, the particles are locked in the fixed position and they only vibrate in that particular position. So now most liquids can be compressed into smaller volume. If I'm going to take this bottle of water here, watch me try and compress it. Okay, there's some compression. Remember, there are spaces between the liquids. There is some compression. You see even the change of the shape of the bottle. You see the shape of the bottle? It's changing. The shape of the bottle changes. So there is some kind of space in between. So most liquids actually can be compressed. Because remember, these spaces that we're talking about, this space there, another space, and another space. Another space there and another space. So when I compress the liquid, I'm forcefully bringing these particles together. I'm forcefully bringing these particles together. As you can see, yeah, I can compress it quite a bit. So let's continue. So particles of a gas, we have been continuously saying the particles of a gas are spaced far apart. The particles of a gas are spaced far apart in comparison to the particles in a liquid that are much closer together and the particles of a solid that are much, much closer together. So this means in the same amount of space, let's say we have the same amount of space, we have that same container, that 2 by 2 by 2 cube, that same amount of space. Gases will have less matter, liquids will have a little more matter in the same space, and solids will have the most matter in the same space. Think of a cube. Just think of a cube. We use the same cube. My line is not quite straight. There we go. Right, we say it's 2 centimeters. 2 centimeters. And in this way, in this direction, also 2 centimeters. All right. Now, so in this space, within this space, if we put a gas will have less matter. What do I mean by less matter? Fewer particles. A liquid will have more matter, definitely more particles than the gas. And then a solid will have the most amount of matter in that same space. The volume is the same, but now we're talking about the number, the amount of matter. The number, the amount. Let's look at a gas. Now, I've tried to compress a solid. I could not. I've tried to compress a liquid. Some success, but not much. So now I'm going to try and compress a balloon that I filled up with air. I'm just going to get a balloon that I filled up with air. There we go. So I tried to compress the solid. No luck there. I tried to compress the liquid. I did have a bit of success. Let's try the gas. So I blew air into this balloon. So this is the air that I blew in is our gas. So if I try and compress it, look at that. I can compress it. I can compress it. I actually can compress it. See? I can compress it. So the reason why I can compress it is because, remember, we said the particles of a gas, the matter, has huge spaces in between. So the gas particles, look at, if the space is there, space there, space between these two, and space between those two. So the gas has huge spaces in between its particles. So that's why I am able to compress that balloon. I can squeeze it and compress it as long as I stay within means and then pop it. So now, why do you think I can compress it? Just give yourself time to think about it. Why do you think I can compress it? It's because of these large spaces. The spaces are so large. When I compress the balloon, I'm bringing the matter, I'm bringing the particles closer together. So there is a lot of space. It's allowing me to compress it to a certain point. So let's talk more about this density of a gas that is not fixed. So gases have the lowest density when we are comparing them to the solids and when we're comparing them to the liquids. They have the smallest, the lowest density. So this means that they can contain a smaller number of particles in a large volume. Remember my cube, my 2 by 2 by 2 cube. That's the same amount of volume. That's 8 cubic centimeters of volume. If I fill it up with a solid, fill another one the same size with the liquid, and fill it in a third one with the gas, the gas will have the least amount of particles, therefore rendering it having a lower density. Okay, so this is why we can compress gases. Their particles can be squeezed closer together to fit into a smaller volume. That's how I could squeeze that balloon. That's how I could squeeze that balloon. So I have another picture of someone squeezing a balloon. They are doing a much better job than I was. See how that balloon has been squeezed, because the particles have huge spaces between them. They are also fewer, so they can be squeezed. So they can be squeezed, they can be brought together. They can be brought together. Let's talk more. So you can also pump more air into a tire and blow more air into a balloon. There are fewer particles in there, so you can actually add more and more and more. Look at this tire here. I can blow more, I can pump more and more and more air. And look at that balloon. It was empty here. After blowing in some air, after blowing in some more air, and there. You see, I can add more and more and more and more. All right. So therefore, the density can change. I would have changed the volume, so I can change the density. So let's do activity 1. I'm going to give you 2 minutes to answer these questions, and then we'll do the solutions together. Let's read the questions first. Why are gases generally less dense than liquids? Why are liquids less dense than solids? I'll give you 2 minutes to answer these questions. Do not forget to send through your answers to 082-760-2630. Okay, welcome back, learners. I hope you're sending through your answers to our WhatsApp line, which is 082-760 and 2630. We have a team that is waiting to respond to all of your questions and any of the responses to the exercise. So now let's look at our activity 1. Why are gases generally less dense than liquids? And why are liquids less dense than solids? Okay, so gases are generally less dense than liquids because their particles are much further apart than the particles of a liquid. If you remember now how the particles in a gas are structured, and if you remember how the particles in a liquid are structured, the particles in a gas have much more space. If we just take 2 squares there, then I'll draw the particles of a gas here and the liquid there. So the particles of a gas would be spaced in that arrangement, and then for the liquid there is space, but the space is much smaller than the space in the gas. So that's why gases are generally less dense than liquids. And then why are liquids less dense than solids? Their particles are much further apart than the particles of the solid. I'm going to draw another square here. There we go. I'll draw the liquid particles here and the solid ones there. So if this was a solid, the particles would be packed in such that there is no space. And then if this was a liquid, there would be some space in between the particles. So that's where the density differs. That's where the density differs. Let's move on to our second activity. So this is activity 2. I'm going to read out the questions. Please do send in your responses. So for all these questions, we're going to refer to this diagram that is above me. Okay. Now, the first question, or rather the main question reads, the container here has some volume and different materials. Right. Which container A, B, or C contains the greatest number of particles? Which container contains the smallest number of particles? Which container A, B, or C contains the material with the greatest mass and why? So this is a two-part question. You mention which container contains the greatest mass and why you are saying so. And then the fourth one, which container has the smallest mass and why do you say so? Still two-part question. And then 1.5 reads, which state has the highest density? Is it the solid in container C, the liquid in container B, or the gas in container A? And also state which has the lowest density and why you say so. So you're going to state which one has the highest density, which one has the lowest density, and why you say so. I'm going to give you 5 minutes to complete this activity. Please do send through your answers to 082 760 2630. Okay, welcome back, grade 8. Don't forget to send through your answers to 082 760 2630. Okay, so here are the questions here. We're just going to have a quick run through and then we'll look at the solutions together. So we have 3 containers: container A, container B, and container C. Container A has a gas, container B has a liquid, and container C has a solid. So in the first question, we need to find which container from these 3 has the greatest number of particles, which container from the 3 has the smallest number of particles, and which container, A, B, or C, contains material with the greatest mass. And we should say why. And then which container has the smallest mass and why we're saying so, and which one has the highest density, why we're saying so, and which one has the lowest density and why we're saying so. So let's start off with the first one. So which of the 3 containers, A, which had the gas, B, which had the liquid, and C, which had the solid, had the greatest number of particles? If you wrote container C, you got it correct. If you wrote container C, you got it correct. Now, the second one, which container contains the smallest number of particles? So it's a matter of just looking. If you want to count the number of particles, you would have counted, and it is container A. If you wrote container A, you got the question correct. Now, the third question, which container A, B, or C contains the material with the greatest mass and why? The container is container C. Why am I saying it's container C? Let's look at the solution together. The container with the most particles would contain the greatest mass. So container C has the greatest mass. If you remember, container C was the solid. Container C was the solid and it had the most number of particles. Remember, the particles in a solid, they are more. Why do we say they're more? Because they are closely packed together. So the solid would have the most number of particles. So if we're going by the number of particles being directly proportional to the mass of that material, the one with the most number of particles will then have the greatest mass, which would be our container C. Now, question 4. Which container has the smallest mass and why do you say so? So the container with the smallest mass is A. So now let's figure out why we're saying it is container A. So container A, the gas, had the least number of particles. I'm sure if you remember the diagram, you saw you could literally count 1, 2, 3, 4, 5 gas particles. So with the least, if we're going by number of particles, the more the number of particles, the greater the mass. So which also means that the less the number of particles, the smaller the mass. So which means container A, which is the gas, has the smallest mass, has the smallest mass. Now, our fifth question, 1.5. Which state between the gas state, liquid state, solid state, which state has the highest density? Is it the solid in container A? Is it the liquid in container B? Or is it the gas in container C? And which state has the lowest density amongst those 3, A, B, and C? And why do you say so? So the solid, I'm saying the solid container C has the highest density because it has the greatest mass. If you remember, the formula for density is mass over volume. So if your numerator is quite large, then you will result in a larger density. It is more dense, its particles are closely packed to each other, it has more particles. While judging by the mass, the gas has the lowest density because it has the smallest mass. We have confirmed already that container A has the smallest mass because the number of particles is actually the least. Now, all three containers were assumed to have the same volume. So with the same volume to all three containers having the same volume, then we can say that the the highest density belongs to the container with the greatest mass. So the gas having the least mass, the smallest mass, will definitely also have the least density. Okay, so let's summarize everything that we have learned together. How density relates to the states of matter and the densities of different states of matter. The first one. So in general, we are saying gases are less dense than liquids. In general, we're saying gases are less dense than liquids. If you remember from what we talked about today, we said we're talking about the states of matter. So it's the way that the particles in the gas and in the liquid are arranged, the way in which those particles are arranged. So if we look at the particles in a gas, they have big spaces in between them. They have big spaces in between them. That is as a result of weak forces of attraction that are holding the gases. So them having big spaces in between them means that they generally have a smaller mass. Here we're assuming the volume is the same. So with the same volume, the gas will have a smaller mass. So now when we take a same volume of the liquid and look at the way that particles in a liquid are arranged, particles in a liquid are actually much closer in comparison to the particles of a gas. So if we go by mass, we say that the mass of a gas will be less in the same volume than the mass of a liquid in the same volume, thereby making the gas less dense than the liquid. Our second point that we learned today is that liquids are less dense than solids. It goes back to the way the particles are arranged, the way the particles are arranged. We look at a container that has the same volume. If we look at a situation that has the same volume, the particles in the solid would be much closely packed in comparison to the particles in a liquid. There are more spaces in between liquid particles. That is why we can pour our cold drink, we can pour our tea, because the particles can flow on top of each other. They can flow. So the particles in a solid are in a fixed position, in that fixed rigid position. They can just vibrate around that locus. They can just vibrate around that locus. Okay, so those are the differences. So the liquid having more spaces in between means less number of particles. Remember, the less spaces between, the more particles there. So having liquids having more spaces in between, it means the particles are fewer, which also means that in the same volume we'll have different masses. The mass of the solid will be greater than the mass of the liquid. With the exception of ice, because ice is less dense than water. Do you remember why we said ice is less dense than water? Okay, let's remind each other again. So when water freezes, when it freezes, it becomes ice, right? So when water freezes and becomes ice, there's a space. The space between the particles becomes greater. The space between the particles becomes larger. Remember the example we gave of putting your 2-liter cold drink bottle in the freezer, and you forget it there and you leave it there, and when you get there, the ice, the frozen cold drink has filled up the entire bottle. It has filled up the entire bottle, even if maybe it was just leaving a tiny space like so. So when a liquid freezes, the spaces between the liquid becomes larger. The spaces between the liquid becomes larger. The liquid's particles becomes larger. So then it increases the volume. Remember, we defined volume as the space occupied by an object. So when that when that water is freezing and that ice is forming, it fills up the entire bottle, increasing the space that it has occupied. So it has occupied more space, the volume has increased in the same mass. The volume has increased in the same mass. So when the volume in the same mass has increased, it lowers the density of the ice. The density of the ice is lowered. So once the density of the ice is lowered, the density of the liquid now becomes higher than that of the ice, because the liquid's particles are now much, much closely packed in comparison to the particles in the ice. So that is why water is more dense than the ice. So when you take your ice cube on a hot day and you are drinking your water, and then you put that ice cube inside a glass of water, it's going to flow. So that's how the density of water is quite different. So that is how the ice, that is because when the ice freezes, when the water freezes, the spaces between the particles increases, and then the volume increases, and then the ice becomes less dense than the water, hence the ice floats. That's why you find those big icebergs floating in the ocean, floating in the sea. So this is the particle arrangement, what I was just saying. This is because of the way their particles are arranged and the mass of the individual particles and the mass of the individual particle. So I've created a table. So this table will help you to understand the different states of matter and their density and their volume. Okay, so we have solids, liquids, and gases. So we're going to compare a certain property. So with the solids are not very compressible. Remember with my Rubik's Cube, I tried so hard to compress it, but I could not compress it at all. This is because these particles are already tightly packed, and there are very small spaces in between, such that the particles themselves are in a fixed position and cannot move from point A to B. They can simply vibrate within that position, within that same position. So solids are not very compressible. Liquids are compressible, not that much, but compressible. When you get home, or when you have during your break time, you can go and fill in a bottle of water and then try to compress it. See how far you can go. Liquids are compressible, but because the spaces between the liquid particles are not as big as those in gases, so you can only do so much. So because the spaces, so what you'll be doing as you're trying to compress the liquids, the particles will be just sliding on top of each other. So liquids are compressible, but not that much. And then gases are highly compressible. Remember, we said in the same volume we will have the least number of gas particles. So meaning we can have a situation where we can compress, we can press. Remember with the red balloon, I was able to compress the red balloon because there are spaces, there are large spaces and much fewer gas particles, or there's much less of the gas matter. So that's how I could compress that balloon. That's why I could compress that balloon. And then when we talk about density, solids generally have the highest density because of the way their particles are tightly packed. They have a larger number of particles in the same volume, and they have a larger mass in the same volume. And then with liquids, liquids also have a high density in comparison to gases because they have a larger number of particles in comparison with the gas, and which means that in the same volume, if we're talking about 1 cubic centimeter of a volume, if we're talking about 1 cubic centimeter of volume in the specific volume, the liquid will have a higher density. And then with the gases have a lower density because of their low mass and low number of gas particles. They have a low mass and a low number of gas particles. And then solids have a definite shape. Remember my cube? That cube will always be a cube. It's a definite shape. So we have different kinds of solids. Here's my pen. It's a solid. It's a different kind of solid. I can pinch it as much as I want. I won't change the shape. And then liquids have a definite volume. You can take 1 liter of liquid, 1 liter of milk, pour it in a 2-liter container. It's still going to be 1 liter. It's not going to change. It's still going to be 1 liter. And the gas fills up a container. If I have 1 liter of gas and I transfer that 1 liter of gas into a 2-liter container, it is going to be 2 liters of gas. Because remember, the gas fills the available space that is there. The gas fills the available space that is there. And then the solid will always be a square solid. And then the shape of a liquid. Liquids always take the shape of the container. If you take 1 liter of milk and pour it into a mug, it's going to take the shape of the mug. If you transfer that 1 liter from the mug into a bottle, it's going to take the shape of the bottle. So they take the shape of the container. So they don't have a definite shape. And then with gases also assume the shape of the container. If you put your gas in a round balloon, it's going to have a round shape. If you put your gas in a square bottle, it's going to be a square shape. So these are the properties of the 3 states of matter, which is your gas, your liquid, and your solid. Okay, in our next lesson, we're going to be learning about the density of different materials. So today we learned about the densities of different states of matter. Next week, we're going to learn about the density of different materials. All right, thank you so much for joining me in this lesson, grade 8. Do not forget to sanitize, wear your mask, and keep social distance. Until next time, goodbye.